Hello there, everybody. Welcome to this episode of Infection Control Matters. I'm here with Brett.
G'day.
Hello. And a good friend of mine, Aristotelis Papadimitriou. And we're going to talk about a recent systematic review he's done, which is called Breaking the Chain of Infection, Systematic Review of Environmental Decontamination of Candidozyma auris 2017 to 2025. So it's bang up to date. Firstly, why have you done this systematic review?
Well, this is part of my PhD project, and this is the first paper that we published along with my supervisor, Professor Georgi Evrioni, at the Medical School of Athens. And the theme of the PhD is Candidozyma auris, disinfection, as a part of environmental hygiene, and we are focusing mainly on dry surface biofilms. And so we wanted to see what is out there in the literature about auris, because this is something new. In Greece, it became endemic in a blink of an eye. Just in 3 to 4 years, we are all flooded with Candidozyma auris cases, mainly colonizations and infections, mostly bloodstream infections. And we all know that it's a new fungus, that it behaves just like MDR gram-negatives. And it spreads like wildfire. And of course, we all know that it survives extremely well in the environment. It's very adaptable. And so far, the main instructions we were issuing in our hospitals and mainly high-risk departments like ICUs was treat it like C. diff. But we are not quite sure that this is enough. Maybe we should go a little bit further on disinfection.
Okay, and this is of importance to you because you're working in an oncology hospital, aren't you?
Yeah,
so it's
yeah.
very high risk.
I work.
Well, yeah, I was just going to ask, the problem you face in your hospital when you talk about infections and bloodstream infections. Look, how on a given day in your role in IPC or in a week, are you seeing like 1 or 2 cases a week? Are you seeing multiple? Are you seeing 1 or 2 a month? What's the sort of numbers you? Yeah.
Well, I live in a highly endemic country for AMR and MDROs. In my hospital, the first Candidozyma auris infection in the ICU was back in 2022. And afterwards, we got flooded. Mainly, there are colonization cases, especially in the ICU. We do see sporadic cases in the oncology and hematology departments, mainly patients that came from other hospitals. So there is endemicity, and nowadays, every week we do get 2 to 3 colonization cases, and per month we do have 1 or 2 cases of bloodstream infection in the ICU mainly.
Yeah.
But we expect that it will get worse.
Yeah.
Yeah.
And what's your current screening practice look like for it?
Well, patients admitted in the ICU are screened on admission, and after that, weekly.
Yeah.
Patients in the departments are not screened,
Yeah. Okay.
except if there's a special flagging on the patient. But the infection control department, in fact, the infection control committee, because in reality in Greece there are no real IPC departments, it's only the IPC committee. We do periodically screen for colonization, so we do a prevalence surveillance with screening the patients, and we go around in the departments and do all the swabbing. And we've just added Candidozyma auris, and we are more and more picking up cases in the oncology departments, and there are patients that have been hospitalized in other hospitals. Because, as you can understand, an oncology hospital is usually the receiver from all over the
you're
country.
You're a tertiary referral centre, aren't you? You're collecting people from all over the
Exactly.
country. Okay. Are you able to actually feed back to the hospitals that are sending to you that they have an issue that they may not have been aware of?
Well, there's no formal procedure, but IPC people in Greece, we are few and we know each other.
Yeah.
So we can make a phone call and tell them, we got a patient from you, maybe you should check it, maybe you have a problem in that department, and vice versa.
Okay. So let's look at the findings then. Did you find many papers on this topic? I think there are a number by now.
Well, there were not that many, and we resulted in 39 papers. If I'm not mistaken, and we try to focus on dry surface biofilms, and there are only 5 or 6 papers that dealt with that.
Yeah, because it took a while for people to realise that actually Candidozyma auris does form biofilm.
Yeah.
So all the studies done previously were largely related to planktonic organisms, which isn't the real life at all.
Oh, exactly.
No. Okay. Findings then. Let's talk about that.
Well, findings, as far as we know, what don't work very well. Hypochlorites on highly dosage, let's say 1000 ppm and higher, they do work even on dry surface biofilms. That is dependent on the conditions. And also peracetic acid on at least 2000 ppm or more, and hydrogen peroxide.
Okay.
Mm.
And
So the oxidizing agents.
yeah,
Okay.
yeah. But we shouldn't forget that all the papers are lab tests.
Yeah.
And there is a huge gap between the lab and real world conditions.
And when it's hydrogen peroxide, do the lab tests, are they talking about vaporized hydrogen peroxide or actual direct application with a wipe?
Well,
or
there
something
were
like
papers dealing with both, and
Yeah.
wiping and vaporized. Vaporized seems to work extremely well with planktonic
Yeah.
Candidozyma auris, but on biofilms, it doesn't seem to work very well because it cannot easily penetrate.
Yeah, you gotta get a
It makes
gas.
sense, doesn't it?
Yeah.
Yeah, trying to disrupt
Yeah,
the...
it's like a gas
yeah.
through a
On
jelly
the
or
other
something.
side, UVC probably can penetrate up to a layer. And we shouldn't forget that we are discussing dry surface biofilms. They are very thin. They are not wet biofilms that in many cases they can be seen. So they are very thin, and it looks like the UV can penetrate at least the upper layers of the biofilm.
Okay.
And do you reckon that's enough to cause inactivation?
Well, we are not pretty
Not
sure.
sure,
on that.
yeah.
Yeah, because
yeah.
because biofilms, as far as we know from bacteria, do have persister cells
yeah.
that are practically the designated survivors for the
Yeah,
biofilm
exactly.
colony.
Yes, that's
Yeah.
right. Yeah.
And
Look what they
It's like,
call
it's like that weed that you can't get rid of in your home.
Yeah.
You don't pull it quite out properly and it
And
shoots
there's
up
one little
somewhere
bit.
else.
Yeah, I mean, it's they call them viable but non-culturable, don't
Yeah,
they?
Yeah.
That's,
I mean, do we know if C. auris does that? Forms the persister cell form type of?
well, we
Picture?
are not pretty sure, but it looks like there's a change in their metabolism. So probably there are
Yeah.
something like persister cells with bacteria.
Yeah, well, that's an issue then, because you go and sample it and you grow nothing unless you've got really specialized methods. So your average lab has limited chance.
Yeah, and
of
also
determining that.
environmental sampling, at least with traditional methods and traditional laboratory methodology, usually gives us nothing.
Okay.
We've done that, and we got nothing of the environment, but we couldn't use genomics or even molecular methods. So traditional culturing is not worth the cost and the effort.
Yeah. I mean, C. auris biofilm then, often biofilms are polymicrobial. So do you find, or are there papers that say that the C. auris is in the biofilm with other bacteria, or generally people finding it as like a
Well,
single
it
species
hasn't
biofilm?
been studied extensively about polymicrobial biofilms with Candidozyma auris, but why not?
Yeah.
In real world
I mean, the logic
conditions,
is
yeah,
it should. Yeah.
they
okay.
should coexist, and we do know that polymicrobial biofilms do work in a synergistic way. So bacteria can help other bacteria, or if something changes with the biofilm colony, they can compete each other.
Yeah.
So why not Candidozyma auris too?
Yeah.
Yeah.
Okay.
So apart from the disinfection side, are there other things that struck you from your findings from your review?
Well, I think that we are not paying enough attention to environmental hygiene in healthcare in general. Environmental hygiene is crucial for the food industry. We do know that there are strict environmental rules for computers manufacturing factories and all that, but we don't pay enough attention in the healthcare setting. I don't know why. We don't have fairly good standards, and probably we don't believe much in it, and we don't want to invest a lot in it.
It's tricky, isn't it? Because I mean, we were chatting to somebody the other day, and I didn't know this, that in food service in the United States, you have to be able to prove the concentration of the disinfectant you're using. And that's probably because
At
they're
the
using
point of
doses
use.
at the point of use. And in healthcare, nobody ever thinks about that, really. And I mean, contact time is interesting as well, isn't
Yeah,
it?
of
So
course, of course.
chlorine may work at 1,000 ppm, but what's the contact time like
Well,
compared with
it's
5,000?
usually around 5 minutes. That's
Yeah.
on the papers, and this is also non-real world condition. We
Okay.
want something that works in around 60 seconds up to 2 minutes. Longer than that in real conditions
It's dry,
is not.
isn't it?
yeah,
Yeah,
it's not
especially in
practical.
Greece. I mean,
Yeah.
in summer, it's not going to stay wet for very long.
Exactly. also the environment, room temperature, humidity,
Humidity,
all that plays a role.
Yeah.
And all the standards that exist until now and all the lab tests are on very protected environments.
Yeah.
It's not real world conditions.
No. I mean, the papers you found then, not many on biofilms themselves. Did you find any differences in the substances that were able to be effective on a dry biofilm? You say chlorine does seem to work.
Yeah,
But is that just putting it on the biofilm, or is that actually putting some friction and force into a cleaning
well,
aspect of it?
technically the lab test is just contact
lay it on,
time,
okay.
but we do
In the
we
the
do
real world,
understand
actually,
that
there
in
are
the
other
real
forces.
world we need muscle. If
Yeah.
you want to get rid of bacteria and fungi from the environment, you do need muscle.
Yeah.
And this is another factor that it's very hard to simulate in the lab.
Yeah. I actually did read a couple of papers a while ago showing, depending on the substrate of the wipe you're using, sometimes more pressure means it doesn't work as well, and with others, more pressure works a lot better. So I don't think we know anything enough about substrates.
Can you imagine trying to implement that in the
Oh,
real
could you?
world?
How could you standardise
Not only do you
that?
have to clean it properly, you've got to have the right
You've
pressure.
got to put so many kilograms per square meter.
So let's get cleaning personnel trained on that. How much pressure they must put.
Well, cleaning services are under pressure,
Just
but
coming to training would be a good thing.
it
Anyway.
would.
Yeah. So what's the next steps for you?
Well, we've just finished the first part of the lab test. We finally found a strain that forms good biofilms, and now we will try disinfectants in the laboratory in different contact times, and we'll start with hypochlorites, starting from 500 ppm, and we'll go up and see what happens next.
Okay.
Yeah.
Which clade have you picked?
It's clade 1.
Okay. And where's that from? Where did that originate from in the world?
The laboratory in the Athens Medical School has around 1,500 strains from all over the country.
Okay.
Yeah.
Yeah.
Oh, wow.
But they are mainly clade 1. And another worrisome factor is that during the last year, there is more and more candidin resistance.
Yeah.
The FKS1 mutation is taking over. So
Yeah.
my guess is that probably in the next 2 years, this strain, the practically pan-drug resistant strain, will take over.
The
That's
clade thing is
scary.
interesting, is because if some other clades don't form biofilm as well, they're
that's
unlikely
true.
to be
That's
persisting in the environment so much. So actually, it's not just finding out what you got in your organization. You really should be thinking about what clade you've got.
Exactly.
And if it's a clade 1, like you say, which
exactly.
forms biofilm, then you've got to really go to more to town
exactly,
on cleaning than otherwise. And I wonder if people have thought
It's also a
about that
good one to
aspect.
choose, Clade's one, because it's going to be the hardest to probably.
Yeah. Well, that's
get
right.
rid of.
Yeah. Get rid of the
Yeah,
toughest
so
one. Yeah. And then they should
work
easily
very well.
knock
In
out
fact,
the others.
clade 2, which practically is the original strain from Japan, is much easier to get rid of
Yeah.
the environment. Clade 1 is very persistent, and also clade 3.
All right.
Yeah, but we worked at least in our project with the strains that we have from Greek
Well,
hospitals.
it means practically
and
something to you, doesn't it?
Probably our next steps will be getting some other clades from other laboratories outside Greece and do the same tests and see what happens. And there were papers that we reviewed that included multiple clades.
Yeah.
And also the findings differ. And indeed, clade 1 is the toughest one.
Yeah, I mean, I remember a poster a few years ago from a university in the UK where they stripped out the different components of a quat, because they're all formulations, and different clades, different aspects of the formulation were better against one another. So,
Yeah, exactly.
you could easily say, well, quats don't work. Well, some might, but only against that clade. And again, you wouldn't know that either. So it's just really complicated.
That's
So trying to get to a consistency, sort out on clade 1, well, is contact time any different on things like hydrogen peroxide and peracetic acid? Because they're generally classed as more modern disinfectants. I mean, they're still last century, but have you got any evidence that the contact time could be less with those?
Oh, yeah. It seems like they can do the job in far less time, even compared with hypochlorites.
Okay. But they're more expensive.
Yeah.
Yeah. Even though
So you can opt for them at least in high risk departments
you
or
could.
in outbreaks. I don't know about endemic settings, because I work nowadays in an endemic setting.
Endemic setting,
and
yeah.
this is the problem. we get reports and guidance about outbreaks, but we are endemic. It's our daily routine, and it's very hard to have peracetic acid all over the hospital.
Yeah, sure. Yeah.
It's
And
not
we
only
don't know what to
cost,
do to compatibility of the equipment,
No,
some of
yeah,
which may have been bought
that's
years
another
ago.
aspect.
And
yeah.
nobody would ever have thought, oh, we might have to use peracetic acid on this if your equipment's more than 5 years old.
That's another
Probably the-
aspect.
yeah.
And also you have to deal problems with the problems of its disinfectant. For example, peracetic acid. We tried it on the floor for wiping. It smells vinegar.
Yeah.
It was unbearable for the
Yeah.
staff in the ICU. So we said, that's it.
Yeah.
Go back.
Yeah. It has to be tolerable, doesn't
Yeah,
it? And
yeah, yeah.
tolerated. Otherwise, people won't
Yeah,
do
that's
it.
another factor.
Or they'll dilute it to a level where it's not going to work anyway, just to get rid of the smell. So, yeah, that's not work.
Yeah.
Okay. Well, thanks very
Fantastic.
much. Really enjoyed
Yeah, I
it.
really
Thank you very
appreciate it.
much.
Thanks very much.
Very
And,
nice.
look forward to seeing the rest of the PhD and the findings.
Yeah, well, I'm sure we'll be talking again.
We're sure we will. Okay.
Thank you.
Thanks for joining, everybody.
Bye for now.